Welcome to the third video of section 3.2 on solving linear systems. In this video, we'll continue example 3.2.3. In particular, we're going to use elementary row operations to solve the linear system 2x minus 3y plus 4z is equal to 1, x minus y minus z is equal to minus 1, and minus x plus 2y minus z is equal to minus 2. To begin, we need to write down the augmented matrix of the linear system. To do this, I just have to keep track of the coefficients and constants for each equation. From the first equation, I have 2, minus 3, 4, and 1. From the second equation, I have 1, minus 1, minus 1, and minus 1. From the third equation, I have minus 1, 2, minus 1, and minus 2. I want to remind you of what our goal is. Our goal is to use elementary row operations to reduce this augmented matrix to the following form: 1, 0, 0, minus 4, 0, 1, 0, minus 3, and 0, 0, 1, 0. The reason that we want to do this is because from the matrix I've written in red, we can easily see the solution to the linear system. In particular, from the first row that x has to be equal to minus 4, from the second row that y has to be equal to minus 3, and from the third row that z has to be equal to 0. So what we have is a bit of a puzzle. We need to be able to use elementary row operations to take the augmented matrix that we start with on the left and transform it into the red matrix on the right. Let me remind you what the elementary row operations are so that we can use them. The first thing that I notice is that in the top left position of the red matrix, I have a 1, but in the top left position of the black matrix, I have a 2. I can fix that by applying the elementary row operation. Row 1 swaps with row 2. When I do that, I'm going to use a tilde to tell everyone that I've done an elementary row operation. And I have 1, minus 1, minus 1, minus 1, 2, minus 3, 4, 1. And the third row stays the same, minus 1, 2, minus 1, minus 2. So now I have a 1 in the top left position, just as we have in the red matrix. The second thing I'm going to do is I'm going to move on, and I notice that there's a 0 just below that 1, where I have a 2. What I'm going to do is scale the first row by minus 2. When I scale the first row by minus 2, I'll do this in my head eventually, but let me write it down this time. I have minus 2, 2, 2, and 2. So all that I've done is scaled each of the entries of the first row by 2. The reason that I'll do that is because when I add the scaled minus 2 to the 2 that's already in the second row, that's going to give me a 0 that I'm looking for. Okay, so let's write down the row operation that we need to do. We need to take row 2 and add to it negative 2 times row 1, and we'll place that in the row 2 position. Performing this row operation doesn't change the first row at all, so we leave it alone. 1, minus 1, minus 1, minus 1. The second row, now we have to add the second row in the previous line to the red numbers, giving me 0, minus 1, 6, and 3. And finally, the third row stays the same, minus 1, 2, minus 1, and minus 2. Continuing, I'm going to try to make this entry here a 0 in this minus 1, which is here. I want to make it a 0. This time I can see the row operation a bit easier. I can see that if I add the first row to the third row, that pink minus 1 will cancel out. So I'm going to do the row operation. Row 3 plus row 1 is going to be the new row 3. When I do this, the first row stays the same. The second row stays the same. And finally, the third row, I just have to add the first row and the third row together, giving me 0, 1, minus 2, and minus 3. The next entry that I'm going to try to change is I want to make this entry here a -1. There's a few options that I could do to do this. One thing that I could do is I could swap row 1, or I could swap row 2 and row 3. Another thing that I could do is I could scale the second row by -1. Let's do that. So I'm going to replace row 2 with minus row 2, giving me 1, -1, -1, -1, 0, 1, -6, -3, 0, 1, -2, -3. So this is starting to look more like the matrix that we're trying to get to. The next thing that I'll do is I'll use this one to make a 0 below it. The row operation that I need to do for that is row 3 minus row 2 is the new row 3. This gives me 1, -1, -1, -1, 0, 1, -6, -3, 0, 0. Now I do -2 minus -6, which is 4, and -3 minus -3, which is 0. I can scale the third row to put a 1 where the 4 is. 1/4 row 3 becomes the new row 3, giving me 1, -1, -1, -1, 0, 1, -6, -3, 0, 0, 1, 0. Good. Already we can see that the z has to be equal to 0. So now that I've continued and I've positioned, I have a 1 in the 1, 1 position, I have a 1 in the 2, 2 position, and I have a 1 in the 3, 3 position. One thing to notice is that I've sort of formed this staircase pattern, and you're going to see this time and time again. And in this case, we went down 1 over 1, down 1 over 1. And sometimes it won't be quite so nice, but we will aim for this staircase pattern with 1s along the stairs and 0s below the stairs. Now that I've gotten 0s below the stairs, I can start in the column of variables that's most to the right, and I can start clearing above. So in particular, I'm going to use this 1 in order to get rid of this -6. The row operation that I need to do that is I'll take row 2 and I'll add to it 6 times row 3, and that will become the new row 2. I think I'm out of space, so let's continue above. So the first row will stay the same, 1, -1, -1, -1. The second row will change, but not the first two entries, 0, 1. Then I have a 0, and now if the -3 stays the same because when I scale 0 by 6, nothing happens. And finally, the third row also stays the same. Now I'll use this 1 to clear out the -1. This time I'll use the row operation row 1 plus row 3 is the new row 1, giving me 1, -1, 0, -1, 0, 1, 0, -3, and 0, 0, 1, 0. We're almost there. We have one more step. The last step that we need to do is we'll use this 1 in the 2, 2 position to clear out the 1 above it. The row operation that I need for that is row 1 plus row 2 becomes the new row 1. So finally, I have 1, 0, 0. Now I do -1 plus -3, giving me -4, 0, 1, 0, -3, and 0, 0, 1, 0. Again, why is this nice? It's nice because if you read the first row of the matrix, you have that x is equal to -4. The second row of the matrix tells me that y is equal to -3. And finally, The third row of the matrix tells me that z is equal to 0.